Practice with factoring is hugely important. The only way you get good at factoring is to practice, 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 and more practice. Within the videos that I do for practicing, I'm going to often have examples that I want you to work through on your own. In this case, I have 9 examples. I'd like you to go ahead and pause the video here, do all of these yourself, and then check your answers by unpausing, because I'll go through all of these, but rather quickly. So go ahead and pause this video, try them yourself, and then you can check your answer by continuing with the video. All right, so let's do some factoring. 221x plus 28, there's a common 7 in both of those terms. When I take 7 out, I get 3x plus 4 left in the parentheses. If I wanted to check that, I would multiply the 7 back through. 21x plus 28, and that's where we started, so that checks. 32x squared plus 4x, the 4 is common, as well as an x, so we'll take both out. 32x squared divided by 4x is 8x, plus 4x divided by itself is 1. Make sure you have that 1 there. To check this, we multiply back through. 32x squared plus 4x. That's where we started. 9y squared plus 12y minus 6. There is no y in every term, but there is a 3 that could be divided out. So we'll just take the 3 out. 3y squared, when we take it out of the 9y squared, plus 12y divided by 3 is 4y. Negative 6 divided by 3 is negative 2. Checking that, 9y squared plus 12y minus 6 is where we started, so that checks. Next example. 32x cubed y squared minus 24x cubed y minus 16x squared y. A lot going on there. If you look, every term has an x and a y in it at least. And then 32, 24, and 16, they definitely have a 2 in common, but if you look more closely, there's a 4. And then the biggest number is that they each have an 8 in common. So we'll take the 8 out. Now, the x's, you might think there's just a single x, but if you look carefully, there's an x cubed, an x cubed, and an x squared. So actually, there's at least 2 x's in each term, an x squared that we can take out of each term. In terms of the y's, y squared, y, and y means there's a single y that's common for each. So when we take 8x squared y out, just take your time, think number first. 32 divided by 8 is 4. X cubed divided by x squared is x. Y squared divided by y is y. So there's your first division. Now go to the next term. Negative 24 divided by 8 is negative 3. X cubed divided by x squared is x. Y divided by y is 1. So we have negative 3x left. And then finally divide out by the negative 16x squared y. So we get negative 2. X squared divided by x squared is 1, y divided by y is 1, so actually all we're left there is 2. So checking this, and this one was big, so it's really important to check. 8 times 4 is 32, x squared times x is x cubed, y times y is y squared, minus, going on to the next term, 24, x squared times x is x cubed, and a y, and then finally minus 16, x squared y is left, and if you now compare, that's where we started. All right, just put some break between each problem. Next problem, 11x squared minus 23. When we look closely there is no x in common. And then 11, the only thing you've taken 11 is 1 and 11, and 11 won't go into 23. So there's actually nothing in common between these two terms. So this would not be factorable. It's not factorable in terms of anything that would be helpful to us. Sometimes we also call that a prime polynomial. So one thing to note is that not everything factors. In the next example, y is common to both terms, so we'll take it out. We're going to be left with x minus 3. So if you wanted to check that, y times x is xy, y times 3 is minus 3y. That's where we started. In the next one, I know it's kind of silly, but smiley face is common, and when you take it out, you get x minus 3. Again, you could multiply that through. X times smiley face is x times smiley face, minus 3 times smiley face. And that's where we started. Oh, my smiley face doesn't look like a smiley face. There we go. Next one. What's common is the 5, pi, and r. Notice that they're both in parentheses to show it off. That's sometimes something that'll come up. So when we take that out, we're going to divide it out and be left with x in the front, and in the second term be left with a minus 3. So again, we can check that x times this stuff, right? In parentheses, 5 pi r, minus 3 times that same stuff, 5 pi r. And finally, x times x plus 7 minus 3 times x plus 7. Even though it feels a little odd, this x plus 7 that's in parentheses, it's kind of like that smiley face to the 5 pi r. It is common, so we can take it out front. And when you take it out front, what is left is going to be the x, when you divide this out, and the 9 minus 3. Just like in the last two examples. And there's a method to my madness here of having 3 very similar examples, because we're going to be using this technique as we continue on to look at the next idea. So x plus 7 times x plus 3 is your final result. Notice a binomial times a binomial. Again, you can multiply that out to check. I'll leave that for you.